Hey guys, so today we are going to learn about a very special topic. So without further ado, let's learn about inverse derivatives. Yay! I swear guys, it'll be fun. Oh, and we have a little friend. This is Leroy. He's going to be our turtle companion. And right now, Leroy is asking, what is inverse derivatives? Well, first of all, what are inverses? Inverses are simply the reciprocal. So basically, we are finding the derivative of the reciprocal function. And here's a proof to prove it. Basically, if function f and g are inverses, then g prime of x equals 1 over f prime of g of x. But how do you do that? Here's how. If f and g are inverses and g's domain is x, then f of g of x will equal x. To find the derivative, you will need to apply the chain rule, which will then equal f prime of g of x times g prime of x equals 1. Lastly, you will need to isolate g prime of x, and when you do, you should get 1 over f prime of g of x. Leroy's happy with that answer. Alright, example 1. So f of x equals x cubed minus 2, where x equals 4. The inverse of f equals g of x, and we're trying to find g prime of 4. We are going to start out by plugging in 4 to the equation, so 4 cubed minus 2, which equals 64 minus 2, which equals 62. So we find through that f of 4 equals 62. And since the inverse of x equals g of x, we see that g of 62 equals 4. Now you find the derivative of the function of f, which you will get 3x squared. When you plug 4 into the derivative, then you get 48. Therefore, g prime of 62 is 1 over 48. See, Leroy, it's not that bad. Alright, so we're going to go about finding the inverse derivative another way. Finding inverse derivative using slope. Don't be scared, Leroy. Everything will be okay. Alright, example 2. f of x is differentiable and invertible, ... and it passes through the point 3, 4, and has a slope of 3 over 1, or 3. We want to find the inverse of x, which is g of x, and we're going to find g of x and g prime of x at x equals 4. So we already know that f of 3 equals 4, therefore the inverse would be 4, 3, or g of 4 equals 3. We also know that f prime of 3 equals 3 because the slope is 3 and the derivative is the slope of the tangent line. Therefore, excuse my awkward correction, but the inverse derivative of f would be 4 equals 1 over 3, or g prime of 4 equals 1/3 because it is the inverse. See, Leroy, these problems aren't so bad. Alright, that's about the basic stuff. Now let's start getting into the nitty-gritty and fun stuff. The inverse derivative of trig functions! Woo! Party! Come on, Leroy, you have to be positive about this. You will be able to get this down easily. Okay, let's run through the basic derivatives of these trig functions. First, going over arcsine and cosine, they have pretty much the same derivative, except remember that cosine is the negative version. So remember, cosine is always negative. Next, going over arctan and arccotangent, just like arcsine and arccosine, their derivatives are pretty much equal, except arccotangent is 1 over 1 plus x squared, and just like arccosine, arccotangent is negative, so remember, cotangent is always negative. Lastly, I want to go over arccosecant and arcsecant. Again, the derivatives are almost exactly the same, except one is positive and one is negative. Here, you really need to pay attention to the signs, because here, cosecant is negative, while secant is positive. It's confusing because cosecant is the reciprocal of sine, while secant is the reciprocal of cosine. Earlier, we looked at arcsine and arccosine. There, sine was positive, cosine was negative. A lot of people might think, oh, because cosecant is the reciprocal of sine, it's definitely positive. No, don't think that. So the reciprocal of sine, which is cosecant, is always going to be negative because it's the opposite. It goes for the same with secant and cosine. Cosine is negative, but its reciprocal will be positive, and it will always be like that. And I also very much exaggerated the signs so you can see which one is positive and which one is negative. I am now going to go over one of the inverse trig proofs. First, let's go over the proof of the inverse derivative of sine. So we start with y equals arcsine of x. To attack this, you are going to want to first multiply sine to both sides. By doing so, this cancels out the arcsine. So you will end up with sine of y equals x. Then you take the derivative and you will get cosine y times y prime equals 1. Then you want to isolate y prime and you'll get 1 over cosine of y. Then you are going to want to draw your handy dandy grid and triangle. You know the hypotenuse is 1, and through the Pythagorean theorem you learn that one of the sides is x and the other one is radical 1 minus x squared. The cosine of y is radical 1 minus x squared, and once you divide it by 1, you learn that it's 1 over radical 1 minus x squared. And you're done! See, Leroy, are you starting to understand it? The last thing we are going to do is we're going to tie our normal problems. For our example, f of x equals the inverse of sine of cosine of x when x equals pi over 4. And remember, we're trying to find g of x and g prime of x. For this, we need our handy-dandy calculator. Then you plug in pi over 4 and you get arcsine of cosine of pi over 4. Then you draw your handy-dandy grid and triangle, and because pi over 4 is where 45, 45, 90 special triangle is, you know that your sides are 1, 1, and the hypotenuse is radical 2. From your grid, you find out that f pi of 4 equals arcsine of 1 over radical 2. Sorry, the super zoom on my phone broke, but there I am circling the blue button on a TI 84 Plus that says second. Press that first when using your calculator. After pressing second, there's a button with the word apps in purple. Under that is the sine button. If you press that, you should get the inverse of sine, and then you will type in 1, the divided by sine, and then radical 2. The calculator will give you an answer of 0.79. Hence the inverse of f, which is g of x, g of 0.79 is pi over 4. Then you find the derivative, which will be negative sine of x over radical 1 minus sine of x squared. Plug in x, and you get negative 1 over radical 2 over radical 1 minus 1/2. Then you divide, and you cross multiply, and you get negative 1, which, when you plug into the inverse, you get g prime of 7.79 is negative 1 because 1 over 1 is 1. See, Leroy? I told you it'd be easy and you'd get it. Well, that's all for today, so until next time.